take a look at the unit circle and some quadrantal angles. Okay, the first thing I want you to do is recall your Algebra 1, and if this was a piece of graph paper, on the coordinate plane, this point right here would have what kind of coordinates? 1 to the right, 0 up and down. This would have the point 1, 0. How about this point here, due north? Yep, 0, 1. Due west, -1, 0. And due south, 0, -1. Okay, we have to remember when we are doing these that it's x, y. Okay, that's going to help us a lot with trigonometry and unit circle and sine and cosine and things like that. First of all, a unit circle is a circle whose radius is 1 unit, and the center is on the origin. So let's draw a unit circle. I'm going to put the center on the origin, and the size of my nice perfect circle is going to have a radius of 1. Okay? That means that this right here, this radius, this is length 1. I'm going to go ahead and draw a triangle. You always go from the point on the circle directly to the x-axis. So you always use the x-axis as the horizontal. You go up and down for a vertical, and then of course the hypotenuse is going to be a diagonal. This angle right here is called theta. That's the angle that forms that triangle. The length right here going horizontally is going to be x units. And up and down, we're going to call that a length of y. The x direction, the y direction. Okay, let's go ahead and take a look at this. Sine of angle theta. Remember, SOHCAHTOA, sine is opposite over hypotenuse. That's y over 1, or just simply a y. When the unit circle has hypotenuse 1, that 1 does not really need to be mentioned. All right, let's do cosine. Cosine is adjacent over hypotenuse, so x over 1 is simply x. Okay, so when I say sine, you think y. When I say cosine, you think x. All right, let's do a tangent here. Tangent is opposite over adjacent, and that's y over x. Okay, but if you want to talk trigonometrically, then when I say y, you would think sine, and when I say x, you would think cosine. So when I say tangent, you think sine over cosine. Okay, and we definitely have to remember these. So remember, cosine is the x value, and sine is the y value. Okay, a couple ways that you can remember that. It always goes x, y. It goes in alphabetical order. And so does cosine, sine. If I say find me the cosine, you would look in the x place. If I say find the sine, you would look in the y place. And one more time, if I say tangent, then you're going to have to take the sine over the cosine. Okay, let's go ahead and do some practice here. So we've got point P, which is a point on the unit circle. So let's go ahead and draw a nice graph here. I'll draw a nice unit circle graph. So the hypotenuse, the radius is length 1. Let's see, the point is -1/2, positive radical 3/2. That point is in quadrant 2. Okay, so that's the point right there. So you go directly to the x-axis. The hypotenuse goes from the point to the origin, okay, and we're going to label this. So if the x value right here is -1/2, and then the y value is radical 3/2, how long is the hypotenuse? You could calculate the Pythagorean theorem if you'd like, or we could just look here and say, oh, it's a unit circle? That means the hypotenuse is 1. Okay, and then the angle I'm going to put right there inside of the triangle. Find the 6 trigonometric values. Let me just mention that the hypotenuse is always positive. Okay, the hypotenuse is always positive. The x value and the y value could be positive or negative depending on the direction. So let's see. First, let's calculate sine of theta. Sine is opposite over hypotenuse. Oh, but remember, when the hypotenuse is 1, when I say sine, you think y. The y value is radical 3 over 2. When I say cosine, you say x. The x value is negative 1/2. And when I say tangent, you say sine over cosine. Sine over cosine. So let's take radical 3/2 and divide it by negative 1/2. Okay, now we're going to clean this up a little bit, and I'm going to show you guys a over 2 trick. He has a denominator of 2, and this one has a denominator of 2. Can you cancel a denominator with a denominator? Well, certainly, that seems fair. The 2's are going to cancel out, and so what we have left is negative radical 3. All right, that's only 3 values, though. We have to find all 6 trig values. The reciprocal of sine is cosecant. Reciprocal of cosine is secant of theta, and tangent goes with cotangent. And now we're just going to flip these upside down. So we're going to flip and get 2 over radical 3. Reciprocate that one and get negative 2. Reciprocate this one and get negative 1 over radical 3. I always put the negative in the numerator. Now, a couple of these are not ready yet. We're going to have to rationalize this first one here. Multiply top and bottom by radical 3. So the final answer is 2 radical 3 over 3. Secant looks good. We don't have to change that one at all. But we do have to reciprocate or rationalize cotangent. So we'll multiply top and bottom by radical 3 and get negative radical 3 over 3. Our first unit circle problem. Okay, let's try it again. We're going to draw our unit circle. It says unit circle, so that means the hypotenuse is going to be 1. Which quadrant is point P going to be in? Since it's positive, comma, negative. Let's go ahead and draw the point in quadrant 4. You always put the hypotenuse from the origin to the point. You're always going to go directly to the x-axis, and the angle theta is right there. All right, let's put our information on this triangle. It says that the x value is 2 radical 2 over 3. This is x, comma, y, or cosine, comma, sine. The sine value is negative 1/3, and the hypotenuse is 1. Okay, I say sine, you say y, negative 1/3. I say cosine, you say x, 2 radical 2 over 3. I say tangent, you say sine over cosine, negative 1/3 divided by 2 radical 2 over 3. The sine over the cosine. All right, let's go ahead and do our over 3 trick. Let's cancel those out. And so we have negative 1 over 2 radical 2. Now that one is definitely going to have to get rationalized. I'll multiply top and bottom by radical 2. And that gives us negative radical 2 over radical 2 times radical 2. These guys here make a plane 2 times another plane 2 makes a 4. Okay, let's go ahead and find the 3 reciprocal functions. The reciprocal of sine is cosecant. Reciprocal of cosine is secant of theta, and tangent goes with cotangent. The reciprocal of negative 1/3 is negative 3. You don't change the opposite, you just flip it. Let's go ahead and flip this one over. It's going to be 3 over 2 radical 2. That one's going to need some work. And if I reciprocate this one, put the radical in the bottom, that's going to be ugly. Maybe what I'll do is go look right here. Before I rationalize, I'll just flip that one. Negative 2 radical 2. That's a lot easier to reciprocate because then the radical comes upstairs. Let's go ahead and rationalize this one by multiplying by some radical 2's. So the numerator is 3 radical 2, and the denominator is a 4. Okay, so So that's some work with points and the unit circle. Things are going to get a little bit easier here when we have our quadrantal angles. Okay, so first of all, let's go ahead and draw a nice unit circle. That means that the radius is 1. Okay, so let's go ahead and label some of these points. The point that is due north has what kind of coordinates again? 0, 1. East is 1, 0. Due south is 0, -1. Due west is -1, 0. You have to be careful with these because sometimes people switch the 0 and the 1. Okay. All right, now we're going to look at this, okay, and we're going to evaluate the sine, the cosine, tangent for an angle of 0 degrees. An angle of 0 degrees would start right here and swing 0 degrees. So we're looking at this point. 0 degrees is right here, 0 degrees. When I say sine, you think y. Okay, so the answer is 0. So you're looking at either the x value or the y value. All right, what's the cosine of 0 degrees? Go to 0 degrees. When I say cosine, you look at the x number, and you tell me 1. 1, okay, good job. Tangent is sine over cosine. So what is 0 divided by 1 make? Do not leave your answer unfinished. Go ahead and tell me what that actually is. 0 over 1 is 0. Remember that cute little thing I showed you one time? This is okay, but this, no. You don't want to have 0 down there. That would make undefined. Okay, but this is okay. This makes a 0. Okay, let's do another one. This time we're going to go ahead and evaluate pi over 2. Okay, so the first thing I need to ask you, where is pi over 2? You put the initial ray on the positive x-axis and you swing up this much. So pi over 2 is right here. Pi over 2, an angle of pi over 2 takes you right here to 90 degrees due north. So that's where you're looking. When I say sine of pi over 2, you say 1. You always have to say an angle, sine of an angle, or cosine of some angle. What's the cosine of angle pi over 2? Go to that angle, go to that x value, and tell me 0. Tangent for pi over 2 is sine over cosine, and 1 divided by 0 makes? That's right, undefined. Make sure you finish that. Don't leave your answer as a problem. Okay, 180 degrees. Let's go over here and think about an angle for 180 degrees. It's going to be looking due west. Okay, we got our points right there. I say sine of 180 degrees. You say 0. Cosine of 180 degrees is -1. And tangent is the sine over cosine, which is going to make a 0. Okay, I think we're getting the hang of this. So unit circle is just a matter of knowing the points and knowing sine and cosine. Okay, 3 pi over 2. 1 pi over 2 is due north. 1 out of 2, 2 out of 2, so 3 out of 2 is going to be due south. Okay, there you are. Keep those in mind. Sine of 3 pi over 2, -1. Cosine for 3 pi over 2, 0. And tangent for 3 pi over 2, take your sine answer divided by your cosine answer, and that is going to make undefined. Undefined. Okay, now we're going to try to do some problems here. And the way that I highly recommend doing trigonometry is thinking and even drawing where are these places. Okay, so the first problem here is 3 pi. So let's just do a little doodle for 3 pi. 3 pi is 1 pi, 2 pi, 3 pi. So you're thinking due west. Now that you're looking due west, why don't you go ahead and tell me those points? The coordinates of the point is -1, 0. Okay, but I said sine of 3 pi. So looking at this, the sine, when I say sine, you think y, and the answer is 0. So you're going to have to start imagining these little graphs in your mind. Let's do another one. Cosine for -270. All right, negative means you're going to swing down. Swing down 90, 180, 270. Okay, here you are. This point due north is 0, 1. This says cosine, so you think x, and you say 0. Okay, let's keep going. If these doodles help, I highly recommend them the first couple days. 3 pi over 2. Okay, where is 3 pi over 2? 1 out of 2, 2 out of 2, 3 out of 2. Okay, so we're just doing the quadrantal angles for today. We'll do the other ones tomorrow. This point is 0, comma, -1. When I say tangent, you think sine over cosine. Sine over cosine. -1 over 0 is undefined. Undefined. Okay, -6 pi. All right, let's swing negatively. -1, 2, 3, 4, 5. Oh, -6 pi is right here. Okay, right there at 0, 0 degrees. The point here is 1, comma, 0. And this says cosecant. Cosecant is the reciprocal of sine. So we're going to take a look at this sine right here, which is 0, and we're going to have to reciprocate it. So not 0, but 1 over 0. Take the sine answer and flip it, and that makes undefined. Okay, let's keep going. 0 degrees, well, that's easy. It's right here. 0 degrees has the coordinates 1, comma, 0. Cotangent. Well, that's not tangent. Okay, let's see. I know tangent is sine over cosine. So cotangent must be cosine over sine. Must be the flip of that, the reciprocal. So let's take our cosine divided by our sine. 1 divided by 0 is undefined. Okay, last one. Pi over 2 is due north, 90 degrees. The point here is 0, comma, 1. And this is secant. Secant is the reciprocal of who? Of cosine. So I want you to look at this cosine answer and reciprocate it. So 1 over 0 makes undefined. Lots of undefined answers here. If it said take the 1, what's the reciprocal of 1? Oh, just a 1. Okay, those are good examples for practice. Okay, find the exact values of each of the 6 trig functions. Okay, I certainly will. If the angle 4, -3 is the point. Okay, so let's draw our circle. Where are we going to put the point for a positive, comma, a negative? Well, that's going to be in quadrant 4, right here. So I've got a point 4, comma, -3. So this is 4. This value here is -3, and the hypotenuse is, well, it certainly can't be 1. The hypotenuse has to be the longest side. Does anybody know what a triangle that's a 3 and a 4 have to have for the hypotenuse? If you don't know, we could always do Pythagorean theorem. 4 squared plus -3 squared equals c squared, but we're going to get 5. Okay, so an important question, is this a unit circle? No, this is not a unit circle. Okay, so when I say sine, you can't say y. That's only unit circle stuff. Okay, so when I say, let's put our theta there. When I say sine, you're going to have to go old school. You're going to have to do the old-fashioned opposite over hypotenuse. -3 over 5. When I say cosine of angle theta, you'll have to do adjacent over hypotenuse. And when I say tangent, there's a couple ways you could do this. The sine over the cosine and cancel the 5s. Or you could just do opposite over adjacent. Anyway, you'll get the job done. This might be a little faster since you've already drawn the picture. Otherwise, you have to cancel the 5s. All right, it's time for the other 3, the reciprocal functions. Why don't you go ahead and pause this video and then see if you can write them down. Okay, did you get them? The reciprocal of sine is cosecant. Reciprocal of cosine is secant. And tangent goes with cotangent. I always remember this because there's a C and an S and a C and an S. That's how I remember those guys. The reciprocals are negative 5/3, positive 5/4, and negative 4/3. Okay, so here's just a little note for you. When I say sine, you think y. When I say cosine, you think x. And tangent is sine over cosine, but only when dealing with the unit circle. Only when dealing with the unit circle. Okay? We might even want to add on here, cotangent of theta would be cosine over sine. Or the tangent ends are flipped, whatever's easier. Oh, look at this. There's one for you to try. All right, go try it, and I'll see you tomorrow.